Welcome back to my channel. This is part 2 of my video series on physical computing in Power Platform. We'll be looking at the basics of physical computing today. I've got to say I was pleasantly surprised by all the feedback I received from you all. I had messages on my LinkedIn, Twitter and WhatsApp. It was brilliant. So please keep them coming, and if you're keen to hear more of this type of content, please subscribe to this channel and use those like and comment buttons and let me know what you think. So let's get started. Now, when we think about computing in general, we think about code and websites and web pages which run on your computers. Or maybe we think about working with Power Platform and Power Apps to build our business apps. But strictly speaking, with Power Platform, we are building apps that run on the Azure platform, which is technically Microsoft's computers. Either which way you look at it, our programs run on some or the other kind of computer. When we build these apps, especially apps that use high level abstract code like Power Effects or Power Automate workflows or expressions in Power Automate, in the background, the code is interacting with one or the other computer's hardware, like a hard disk or a camera or a screen. If we go sufficiently deep down enough, we will hit things like microprocessors and other electronic components. Ultimately, though, all programs work at that level, changing states of one or the other electronic component or a physical device. But then you may ask, how is physical computing any different to these applications that we are already writing? To find an answer to that question, we will need to do a bit of a thought experiment. So let's do that. Let's think about the computer you're using now or your mobile device. When you write apps or programs, even in Power Platform, or even create web pages or websites, are there any devices that are physically present around you or on your disk being directly impacted by it? To put it in another way, is your program making use of the environment where the computer physically sits? Is it changing the nature of things around the computer by interacting with it? I'm guessing the answer is not. Now, let's do one more. Look around the room you're sitting in. You probably have a lot of devices plugged into your wall sockets. Maybe there's a washing machine or an electric heater or a dishwasher or even a table fan. All of them are sitting there waiting for you to flip their switch on so that they can start working and running. These devices have no awareness of your presence or the environment they are in. They are, for a lack of a better word, dumb machines. A table fan cannot sense that it is too warm in the room and that it needs to switch itself on. Or another example, a washing machine cannot recognize what type of water to use depending on the type of clothes that are inside it. It cannot sense the type of clothes that are inside it to make that decision in the first place. Those decisions are left to the humans themselves. These machines are not smart enough to think for themselves. They cannot use the data about their environment to make those decisions. They cannot send a message to another machine and make it do things. Ultimately, none of them have a physical impact on the environment around them. Now, this is where physical computing comes in. With physical computing, you would write programs that interact with the physical devices or sensors and produce effect on the environment around it. You could build a program that uses a sensor that reads the temperature of a room and use that measurement to decide whether the AC or a heater should switch on or not. But how do we do it? Now, what you see here is what is called an electronic circuit. I won't get into the details of the nature and the behavior of electricity and electrons in this video. I think it is too academic for this video. Maybe some other time. Just remember that the circuit you see here has a few components attached to it. You can see a power stabilizer, which supplies power to the circuit. You can see an LED light, and you can also see what is called a resistor. Again, what is a resistor is not important to this discussion or this video. We will cover it in another video. This power stabilizer has a physical switch that turns the current on or off in the circuit. Me, as a human being, am able to make a decision and press that button for the LED to light up. There is no different to you walking into a room and switching on the lights. There is no automation here. There is no special code running anywhere to turn that light on. It is just my finger doing the job. But what if I want to switch on the light when something happens? For example, what if something happens in your Power Automate flow and you want to be alerted to it physically by turning on this light? Which means we need to be able to somehow trigger that switch from a Power Automate flow. Sounds impossible, doesn't it? Or does it? It'll only sound impossible if you think that the switch there is responsible for providing the electric current to the LED for it to light up. Think about it. Is it the switch that is providing the current, or is it the power stabilizer? Switch is simply breaking or enabling the current to flow from the power stabilizer to the light or not. Meaning, if I were to remove the power stabilizer and hook the light up to some other power source, the LED light will still work. The switch is just arbitrary. If I then cut off the power source, then wouldn't that LED switch off? What if the power source is a computer that we can write code with, something like a Raspberry Pi? Now, Raspberry Pis are full-fledged computers that can run programs written in most of the modern computer languages, like Python or JavaScript or even .NET. It can receive data from the internet or send data out as well. Now, I've got a Wi-Fi connector here, with which we can do that. We can build a full-fledged Azure app in this tiny computer. When I bought this, it only cost me about £35. The most important thing about the Pi is not that it is a powerful computer, it is that it has physical pins called GPIO pins, which can be connected to physical devices, in this case, an LED light. Now, these pins can then be controlled within the code that you can run on the computer. We will see how we do it as a part of the series, but think about how powerful that is. A computer which can interact with physical things. Now, I'm going to do some wiring and some coding to show you how I can replace that power source that you saw a bit before with my Pi, and how I can then control it by sending it instructions. That is all from me this week. See you next week when I talk about integrating the Pi with the cloud. Cheers.